It's just a name, but the simplest topic in pure mathematics, and is called complex numbers. The topic is complex numbers. I've said it's just the name, but the simplest topic. Now, when you talk about complex numbers, you really need to think outside the box. Some people will think that the whole thing is quite complex, cannot be managed, okay? So people will think ill about this topic, okay? But we do not really need to think about too much about them, because it's just a simple idea that was developed by a Danish Norwegian mathematician called Caspar Wessel in early 1799, okay? Although there was this man, world's treatise. So people connected and looked at how they can come up with an idea on a plane, okay? The idea of a complex number as a point on a complex plane. So the first person behind it was Danish Norwegian mathematician Caspar Wessel, but the father of a complex number was an idea of Italian mathematicians. One was Girolamo Cardano and Rafael Bombel, but we do not need a history of this. We just look at, really, we want to look at what a complex number is. Well, the aspect is quite very amazing. Now, in a real plane, okay, in a real plane, it is very difficult to solve the equation ax squared plus bx plus c is equal to 0, where a is not 0 and where b squared is less than 4ac. It is very easy. No, it is not very easy to solve for a plane in the case where you have b squared less than 4ac. Anyway, but we may not need this also too much. The idea would be on introducing the square root of -1. After introducing the square root of -1, okay? And this was introduced as I and J, or I or J, it can be I or J on the plane. The problem got easily handled, okay? The problem simply got easily handled. So, in other words, a complex number, okay, is simply written or is represented by an expression in terms of a plus bi. We're going to look at the details of this. Or one can write it as x plus iy or yi, okay? Where a and b are real numbers, or x and y are real numbers. But the I we are using is a symbol with a property that I squared is equals to -1, meaning I is the square root of -1. Now, Here, idea, you can see that I is equal to the square root of -1. However, you're going to come to the algebra of a complex number. Now, this simple thing also, I is equals to -1 under root, was also, this brain was behind a mathematician, a Swiss mathematician called Euler. He's a very common man at the university. We have Euler series, but he's also a common man in the field of mathematics. Traditionally, letters W and Z were always used to stand for a complex number, whereby a complex number would be written as Z is equals to A plus BI, or one can say Z is equals to X plus IY, or one instead of Z can use W. Now, when you look at this, this part without I is called a real part of a complex number. So the real, we denote it as RE. The real of Z is equals to A. And this part with I is called the imaginary part. So we denote it as Im of Z is equals to B. The real is A, the imaginary is B. Imaginary is that part which has got the arbitrary I. All right. So this is a simple logic behind a complex number. So you just need to know the general form, and you need to know the real part and the imaginary part. The real part is the one without I, the imaginary part is the one with the I. Then you need to know what I is equal to square root of -1. But before I take you to all that, let me first give you a simple background of solving the equations involving complex numbers. Maybe from this point, we are going to see how best we can do it, okay? Solving equations involving complex numbers. Solving equations involving complex numbers. Now, for this case, if we are given ax squared plus bx plus c is equals to 0, okay, it would mean that x squared plus b over a x is equals to -c out of a. I've divided by a both sides and brought a c this side. So by completing a square, we shall have x plus b over a squared equaling to b squared over 4a squared minus c over a, which can be simplified as b squared minus 4ac out of 4a squared. So implying that x plus b out of a squared, okay, even I can, okay, squared is equals to b squared minus 4ac out of 4a squared. I'm trying to derive a quadratic formula. So when you take square root both sides, is equal to plus or minus the square root of b squared minus 4ac out of 4a squared. The square root is affecting everything. So it implies that x is equals to -b, when this one comes this side, -b over 2a, because this is the 2a, so it is like the LCM. plus or minus square root b squared minus 4ac everything out of 2a. Now, we've already seen that, or you know that b squared, when b squared is greater or equal to 4ac, when b, let me say, if b squared is greater than 4ac, then the equation has got two real roots. Okay? The equation has got two roots, of which all those two real roots, of which those roots are real. So if b squared, if you find that b squared is greater than 4ac, then the equation has got two roots which are both real. But then if b squared is equals to 4ac, for this case, the equation has got two roots which are repeated and real. Two roots which are repeated and real. But if b squared is less than 4ac, this condition is the one that brings in the complexity of these numbers. So here we say that the equation has got two roots which are not real. So here we shall consider the equations whose roots are not real in this topic. We consider those equations where b squared is less than 4ac, where they are not real, hence complex numbers. So implying that from x is equal to negative b out of 2a plus or minus the square root of b squared minus 4ac over 2a, it would mean that x would be equal to negative b over 2a plus or minus the square root. Now here, if you factorize out negative, to be negative, you can say negative 1 outside, negative 1 into, now if this is positive, then it means that here we have 4ac, that it becomes negative 4ac, then minus b squared. Of course, when you open the brackets here, it goes back to this. It will be negative 4ac plus b squared, which is this. Then everything out of 2a. Okay. So this is the same as negative b over 2a plus or minus. Now, the square root of negative 1, we have already said that it is I. We say that I is equals to the square root of negative 1. So the square root of negative 1 is I, then times the square root of 4ac minus b squared, then everything out of 2a. Now, if I let my p, okay, if I let x to be equal to p plus I2, okay, it would imply that my p would be equal to the part which is real, which is negative b over 2a, negative b over 2a, while my 2 will be that part which is imaginary, the one with an I. So it will be the square root of 4ac minus b squared, everything out of 2a. So that is the idea of complex numbers. Just help me understand the real part and the imaginary part. The real part is the one without I, the imaginary part is the one with the I. Now, before we go to algebra of these complex numbers, let's first work out some examples and see how best we can do it. Solve the following equations. This is like a curtain raiser. Solve the following equations. A, x squared plus 4 is equals to 0. B, m squared plus 2m plus 5 is equals to 0, and C, 2s squared minus 3s plus 4 is equals to 0. So here we are going to use a quadratic formula. Allow me to use a quadratic formula so that will be very fast solution. For the first part A, we have said that x squared is equals to, x squared plus 4 is 0. So we are going to use a quadratic formula, which quadratic formula is, we shall say using x is equals to negative b plus or minus square root of b squared minus 4ac everything over 2a. Substitute here the value of a. If you are to see, the value of a is 1. We don't have b, but the value of c is 4. So if you look at this, it means that our x will be equaling to negative b, but b is 0, so negative 0 is 0. So we shall begin from plus or minus the square root of b squared, which will be 0 squared, which is 0, minus bracket 4 times a, which is 1, times c, which is 4. Everything is out of 2a. 2 times a, but a is 1, so 2. So it means that our x will be equaling to x will be equaling to the square root of negative 16 out of 2. Negative 16 out of 2. Because this is 4 times 4, which is 16 times negative. Negative 16 out of 2. So, but plus or minus. So, our x will be equaling to plus or minus. To get negative 16, it's as if we get 16 under the root times negative 1. This is what gives us negative 16. Then everything is out of 2. Okay? So when you look at this, the square root of 16 is 4, and the square root of negative 1, because this under root and this under root is I. The square root of negative 1 is I out of 2, but plus or minus. So it means that the answer would be plus or minus 2i. And that is the answer. Or alternatively, this answer, alternatively, for that part, you would say that x squared is equals to 4 negative, meaning that x is the same as plus or minus the square root of negative 4. But the square root of negative 4 is the same as the square root of 4 times negative 1. So it means that we are looking at plus or minus the square root of 4 is 2, while the one of negative 1 is I. So that is what we have. Okay. Then for the second part, part B, where you have m squared plus 2m, then plus 5 is 0. Now it means that we shall have our m equaling to minus b plus or minus the square root of b squared minus 4ac out of 2a. Substitute. So it means that our m is going to be equaling to negative b. Now b is 2, so the negative b is negative 2, plus or minus the square root of b squared, which is 2 squared, minus brackets 4 times a, which is 1, times c, which is 5. And everything is out of 2 times a, which is 2 times 1, that is 2. So this is going to be equal to negative 2 plus or minus the square root of, this is 4 minus 20. 4 minus 20, gives us negative 16 out of 2. Okay, so this is the same as negative 2 plus or minus the square root of, to get negative 16, we get 16 times negative 1, but everything is out of 2. So this is the same as negative 2 plus or minus. I bring in the aspect of negative 1 so that I bring the I element. So the square root of 16 here is 4. Okay, but the square root of negative 1 is I. So this is 4, then I, then out of 2. So it is the same as if you divide through by 2, it will be negative 1 plus or minus 2i. So our m is going to be equal to negative 1 plus or minus 2i. And that is your answer. You have solved. Now, I want you to keep observing the form. I want you to keep observing the form very well. The first answer, we'll go to this. The second answer, we'll go to this. Let's solve the third one, and we generalize at the end of it all the general form of a complex number. So if you look at the final question, you have 2s squared minus 3s plus 4 is equals to 0. So it means that our value of a is 2, our value of b is negative 3, and the value of c is 4. So to get the value of s will be negative b. Negative b will be positive 3 now. So it will be 3 plus or minus the square root of b squared. B squared is negative 3 squared, which is 9. But remember always to substitute. So you have to put negative 3 bracket squared minus 4 times a, which is 2, times c, which is 4. Everything is over 2a. So 2 times 2, which is 4. So this is going to be 3 plus or minus, this is 9, this is 8, 32. 9 minus 32. When you get 9 minus 32, what do you get? 8 times 4, 32. Yes, so now for this particular case, we are going to get actually it is 9 minus 32, which is going to give us negative 23. Negative 23 under the root, then out of 4. So this one can say 3 plus or minus the square root of 23 times negative 1 out of 4. So this is 3 plus or minus square root of 23 may not be direct, so let me maintain it as 23, but the square root of negative 1 is I, but then everything out of 4. So this one can be well written as 3 out of 4 plus or minus, because this one is divided by this and this one by this, plus or minus root 23i out of 4. Now, looking at these examples, they can reveal to us the following. These examples 1, 2, and 3 reveal to us that Z is in form of X plus IY. You can see them from this. You have real, imaginary, okay? Where X and Y, all of them are real numbers. The real part of Z is X, as I told you, while the imaginary part is Y. It means that X is the real of Z, while Y is the imaginary of Z. Now, another thing it has revealed to us that solutions of such equations whose roots are complex occur in pairs called conjugates. They occur in pairs called conjugates. That's why after solving, you have plus or minus, plus or minus. A conjugate is like when I have A plus IB, its conjugate is A minus IB, just saying the same. So by getting their solutions appear in pairs as conjugates, the one is 3 plus, if I'm to write for you this one, it would be 3 over 4 plus root 23I over 4. Another one is 3 over 4 minus, because we said plus or minus, minus root 23I out of 4. So it reveals that solutions of such equations, okay, whose roots are complex occur in pairs called conjugates. Is what we call a conjugate. If I say A minus B, the conjugate of that is A plus B. You change a sign, okay? Then, another thing, it has really taught us that an equation cannot have an odd number of complex roots. It cannot have an odd number of complex roots. That's why we have plus or minus. There are two. Okay. Now, also, if I take it to algebra, okay? A moment as I take it to algebra. Okay, so another thing that it can reveal, however, not too much common to rely on, like not too common to be too quite much examined, but let's get it, is that if you have X plus Y as 0, and then X as 0, and also Y as 0, it implies that the two complex numbers are equal. Okay? Two complex numbers are equal if and only if their imaginary parts are equal. You need to know if Z1 is X1 plus IY1 and Z2 is X2 plus IY2, then Z1 and Z2, these two complex numbers, are equal if and only if, you can denote it by triple or rather by double F's. This is if and only if X1 is equal to X2, and if and only if still Y1 is equal to Y2. In that case, when the real parts of two complex numbers and the imaginary parts of the two complex numbers are equal, we say that the complex numbers are also equal. Let's prove this and we see. However, as I've told you, here we are just trying to lay ground proof. If Z1 is equal to Z2, if Z1 is equal to Z2, then it would mean that X1 plus IY1 is equals to X2 plus IY2. When you bring this on this side, it would mean that you have X1 plus IY1 minus X2 minus IY2 is equals to 0. When you do factorize here, you're going to have the real ones, bring the real ones together. You have X1 minus X2, those are the real ones. Then plus, when you factorize out I here, you have I Y1 minus Y2 is equal to 0. So this one would mean that either X1 minus X2 is 0, and also Y1 minus Y2 is 0. So we shall have X1 minus X2 equaling to 0, because here this side, the real part is this, while this side, the real part is 0. So implying that X1 is equals to X2. Then also here, for imaginaries, we have Y1 minus Y2. Compare the imaginary this side, 0, implying that Y1 is equals to Y2, implying that for the two complex numbers to be equal, the real parts must be equal, and so do is supposed to be the imaginary part. Now, from this sweet episode, I'm taking you to algebra of complex numbers. Algebra of complex numbers. Algebra. Algebra of complex numbers. When I say algebra, simply look at adding complex numbers, multiplying complex numbers, subtraction of complex numbers, okay? Something like that. So algebra of complex numbers. Now, when we say algebra of complex numbers, look at addition, subtraction, multiplication, and division. Okay, so now let's begin with the fact. We shall use this, we shall use Z1 as X1 plus IY1 and Z2 as X2 plus IY2. Now, and we are beginning with the addition. Now, the logic you need to know here is that when adding two or more complex numbers, we add the real imaginary, rather we add the real and the imaginary parts of the equations. The ones which are real, you add them together, and the ones which are imaginary, you add them together. For example, for these two complex numbers given, if I want Z1 plus Z2, it will be equal to, I'll get the real part separate, which will be X1 plus another real part, X2. Then plus, these ones are imaginary, but separate I, then say Y1 plus Y2. This is how we add complex numbers. If I am to illustrate this for you with an example, if Z1 is equals to 5 minus 2I, and Z2 is -1 plus 4I, it will mean that if I need Z1 plus Z2, which is going to be 5 minus 2I plus -1 plus 4I. So you add. So it will be 5 minus 1, the ones which are real, deal with them together. 5 minus 1, okay, plus I into, because this one has I and this one has I, but this -2 plus 4. Meaning that if you add these complex numbers, you're supposed to get 4 plus Negative 2 plus 4, that is 2i. That is how we add them. That's how we add them. Let's look at subtraction. If we had considered the same still, if we get z1 minus z2, it is going to be x1 plus iy1 minus x2 plus iy2. So this is the same as real minus real, so it is x1 minus x2 then of course plus I into y1 minus y2. As simple as that. So if we are to use this very illustration here, I'm going to use these ones and subtract now. So it would mean that my z1 minus z2 for these ones is going to be, z1 is 5 minus 2i, while z2, which I'm subtracting, is negative 1 plus 4i. All right? So this is going to be 5, because this is real and negative 1 is real, but you're subtracting. So it is 5 plus 1. So this is minus minus. So 5 plus 1 plus I into negative 2 minus 4. Negative 2, then minus 4. So this is going to be 6 minus 6i. This is how we work on the algebra of complex numbers. Then let's look at multiplication. That is where trouble always try to come. But the moment you come with it from the start, it becomes very easy. Multiplication. Remember, the name suggests the topic wrong. The name is complex numbers, but we are doing easy numbers. So multiplication. Now, whenever we perform multiplication of 2 or more complex numbers, the following must be observed. You must observe that I is equal to the square root of negative 1. Implying that when you square I squared is the same as negative 1. That is the first property you should know. I squared is the same as negative 1 because I squared is the same as square root of negative 1 times square root of negative 1, which cancel. I cubed. To get I cubed, in the case you're multiplying and you find you are going to get I cubed, it means you have I squared already times another I. Okay. So I cubed, this is already negative 1 times I, so it was going to be negative I. I squared is it? Negative 1. So put it negative 1 times I, negative I. Then I power 4. I power 4 is the same as I cubed. Okay, I can say I squared times I squared. I squared is negative 1 times another negative 1. That is 1. Then what if we have I power 5? If you're having I power 5 is the same as I power 3 times I power 2. But this is power 5. Okay, so I power 3, you have it as negative I, while I squared, you have it as negative 1. So negative 1 times negative I, you get I. So this is, of course, I cubed. I cubed is negative I times I squared, which I squared is negative 1. So negative I times negative 1, you get positive I. This algebra means a lot. What about if we want I power 6? I power 6 the same as I cubed times I cubed. But I cubed is negative I times another negative I. Negative I times negative I, you get positive I squared. But positive I squared is negative 1. As simple as that. Then what if you have like I power 8? This is the same as I power 4 times I power 4. I power 4 is 1 times another 1. You get 1. So this is the logic behind multiplication. For example, if we use the other example we had used of Z1 as 5 minus twice I and Z2 as negative 1 plus 4I. If we want these ones to be multiplied, it means that Z1, Z2 is going to be 5 minus 2I times negative 1 plus 4I. 5 times negative 1, that is negative 5. 5 times 4, that is 20I. Negative 2I times negative 1, you get positive 2I. Then negative 2I times 4I. First work on I times I. I times I is negative 1. Then look at negative 2 times 4. That is negative 8. Times that negative 1, you get positive 8. So the final answer is 8 minus 5, that is 3 plus 22I. As simple as that. You need to know how to expand these brackets, especially dealing with the i's. It is negative 2I. It was negative 2I, if I'm to give you a hint. Negative 2I times 4I. That is where the issue is. So 4 times 8, negative 2 times 4, that is negative 8 already. Then I times I is negative 1, which makes it positive 8. As simple as that. As simple as that. Then from here, we go to a part called division. We go to a part called division. Go to a part called division. Of complex numbers. So when dividing the complex number by another, the result can also be is also a complex number. So it can be done like this. If Z1 out of Z2 is P plus IQ, is P plus IQ, for some real numbers, of course, P and Q, then it means that if you cross multiply, you're going to have your Z1 as P plus IQ times Z2. Okay, times Z2. But Z1, we had already seen that Z1 is the same as X1 plus IY1. So this is going to be equal to P plus IQ. I'm trying to derive something for you, into Z2, which is X2 plus IY2. Now, when you expand this, you're going to get PX2 plus IPY2 then plus iqx2, but because of I times I, that is negative, so it will make it minus qy2. So this is the same as px2 minus qy2, those are the real. Then plus the imaginaries, the imaginary, we are having I into py2 plus qx2. Now, this is x plus iy1. Now, if you have x1 plus iy1 is equals to this, equate the real and the imaginary. If you equate the real and the imaginary, you're going to find that your real, which is x1, is equals to the real of this side, px2 minus qy2. Then it would mean that the imaginary, which is y1, is going to be equaling to the imaginary of this side. So that is py2 plus qx2. That's what we're having now. Solving this equation simultaneously will give you the value of p and will give you the value of q. We are going to look at the details of this. Alternatively, if you're having the other values we are having, let me do you an alternative of division. If you have z1 as x1 plus iy1, and if you have z2 as x2 plus iy2, now z1 over z2 is going to be equal to x plus iy1 over, it was x1 over x2 plus iy2. Now, for this case, you have to realize. We have what we call realizing. Okay, so when I say realizing, the denominator we multiply through by the conjugate. So it would be x2 minus iy2, and also here it would be x2 minus iy2. Now, looking at all this, after realizing, you can get the value. After realizing, you can get the value. Expand. So my z1 over z2 would be x1, x2 minus I x1, y2. Then this is plus I x2, y1. Then this is I times I is -1, but here is another negative, so positive y1, y2. Everything is over. When you expand this down, you're going to get x2 squared plus y2 squared. So this x2 times x2, bring it x2 squared. Then here you have y2 squared positive. Now, applying that here, you can factorize out the real and the imaginary. So the real here, we have x1, x2 plus y1, y2. Then the imaginary, we shall have I into x2, y1 minus x1, y2. Everything is over x2 squared plus y2 squared. All right. Having this in your mind, it can give you now a real value that z1 over z2 is equals to, you divide the real, because this is divided by this and this is divided by this. Let me separate them. So it will be x1, x2 plus y1, y2 over x2 squared plus y2 squared. Then plus the imaginary part, that is I x2 y1 minus x1 y2 over x2 squared plus y2 squared. So still you'll get the same answer. I'm going to do you an illustrative example using both alternatives, but the one of realizing is the most reliable one. Is the most reliable one. The one of realizing is the most reliable one. Let me try one example here. Given that Z1 is equals to 2 plus I, and Z2 is equals to 1 minus 3I, find Z1 over Z2. Wow. Now, solution. I will let, this is the first alternative. I don't normally use this, but since we are learning, let's learn all of them. Let Z1 over Z2, because they want us to find the ratio, be x plus I, y. Now, it means that Z1 is equals to x plus IY of Z2. Z1 is 2 plus I, so 2 plus I is equals to x plus IY Z2, which Z2 is 1 minus 3I. Well, now looking at this, we shall have 2 plus I is equal to, expand, you get x minus 3xi plus yi, then I times I, negative 1 times 3, so it will be positive 3y. Now, it would mean that 2 plus I is equal to, correct the real terms, x plus 3y, then plus, you correct the imaginary. So it will be I into y minus 3x. Now, if I'm to get my answer, I will equate the real with real both sides and the imaginary with imaginary. So equating the real parts and imaginary parts, equating the real and imaginary parts. When you equate for the real, this side you have x plus 3y, x plus 3y, and this side the real you have 2. I call it my equation 1. Then this side the imaginary, I have y minus 3x, and this side the imaginary, I have only 1. Now, solve these equations simultaneously. You can do that. Solving these equations simultaneously, you're going to get the value of x as negative 1 over 10, and you're going to get the value of y as 7 out of 10. But you've said that the ratio Z1 over Z2 is x plus IY, but Z1 over Z2 is x plus IY, implying that my answer will be Z1 over Z2 equaling to, it will be equaling to what? X, the value of x, which is negative 1 over 10, plus IY, so plus I, or plus 7I over 10. So still, that is it. That is it. Alternatively, you divide them direct and then you realize. So alternatively, Z1 over Z2 would be equaling to the value of Z1, which was 2 plus I, and Z2, 1 minus 3I. Now, realize. When you're realizing, you multiply the conjugate of the denominator. So 1 plus 3I up. And also here, 2 plus, no. It is 1 minus 3I times 1 plus 3I. So when you do expand this, you'll be getting 2 plus 6I plus I minus 3, because I times I, that is negative 1, times 3, that is minus 3. Out of that thing down is 1 times this, positive, negative, then positive 9. So it is 1 plus 9. Understand the algebra of multiplying the i's, otherwise you can get a problem. So the final answer would be 2 minus 3, that is negative 2. Then 6 plus I, they become 7I. Of course, out of 10. So implying that this one can be worked out as negative 2 over 10 plus 7I over 10. Oh no, 2 minus 3, that is negative 1. Negative 1 over 10 plus 7I over 10, or I7 over 10. So for today, that is what I can do for today. That is what we can discuss, but we are going to do most of the questions. Now, as students who have followed this lesson, I'm going to give you an exercise of multiplication and division. Okay, then we meet properly next time, even solving some equations. Let's specifically look at simplify the following. A 3 plus 4I plus 2 plus 3I. B 2 minus 4I minus 3 to 5 minus 3I. C is 2 plus I minus I. D 4 minus 3I 1 minus I. D 20 out of 3 plus I 2 plus I 1 minus 2I 1 plus I. F 2 plus 3I out of 1 minus I. G 3 plus 4i out of 3 minus 4i minus 3 minus 4i out of 4 plus 4i h 2i over 1 minus I. So let's first practice here on this simple algebra, and then we see how everything will flow. Maybe for part I, you can even do this 2i squared. Now, we shall begin from there, our next lesson, and that lesson will be forming quadratic equations when we are given roots and other operations. We shall move slowly. Now, before the lesson we are going to start, I want you guys to look at the binomial theorem, because we shall be doing some expansion, and you look at solving, rather you look at polynomials, long division. Okay, so before we meet for another lesson, let's all first have ideas on long division and binomial theorem, particularly the Pascal's triangle. I wish you all the best, guys, and we shall link up next time together.